Some foods seem to laugh at time. Honey pulled from ancient tombs is still edible. Salt sits in a cupboard for years. White rice and dried beans can outlast recessions. And a can of soup can survive long enough to make people suspicious. The usual explanation is, it just doesn't expire. But that is not really true. Food does not beat time. It beats the conditions that microbes and chemical reactions need in order to ruin it. To understand why some foods last so long, start with the real enemies. Food spoils because microbes grow, enzymes keep reacting, fats oxidize, or the package fails. So preservation is really about blocking those routes. The two most useful numbers are water activity and pH. Water activity means how much water is actually available for microbes to use. If you drive that low enough, usually around 0.85 or below, you change the game completely. And if you push acidity low enough, below about pH 4.6, many dangerous microbes stop growing or stop making toxin. That is why dry foods matter so much. Sugar, salt, crackers, hardtack, dried beans, white rice, powdered milk, and freeze-dried foods all work on the same basic principle. Microbes need available water. Dry the food, bind the water with salt or sugar, or remove it by freeze-drying, and the microbes lose access to what they need. That is also why honey lasts so absurdly long. Honey is a perfect defensive package. Massive sugar concentration, low water activity, acidic pH, and even extra antimicrobial chemistry such as peroxide generation. Honey is not immortal. It is just an incredibly hostile place for most microbes. Acid is the second big trick. Vinegar keeps because acetic acid makes it self-preserving. Fermented foods keep because the good microbes change the chemistry before the bad ones can take over. Lactic acid bacteria lower the pH and also make antimicrobial compounds. Soy sauce is a great example because it stacks multiple hurdles at once. Fermentation, very high salt, a final acidic pH, and then pasteurization. Food scientists love this approach because every hurdle makes the next one's job easier. Low water, low pH, low oxygen may be a preservative, and suddenly spoilage becomes extremely difficult. Modern industry scales the same ideas with better control. Canning uses heat plus a hermetic seal to create commercial sterility. That is why canned goods can sit at room temperature for years. Aseptic packaging does something similar by sterilizing the product and the package separately and then bringing them together in a sterile system. Freeze-drying removes frozen water by sublimation, which keeps quality high and makes products very easy to store and rehydrate. Irradiation is another tool. It reduces microorganisms and insects, and at high enough doses it can even sterilize foods for very long storage. None of that is magic. It is just precise control of water, heat, oxygen, and contamination. But here is the part people get wrong. Long shelf life is not the same as no risk. Freezing does not kill most bacteria. Drying does not sterilize food. Vacuum sealing is not a cheat code. In fact, reduced oxygen can be dangerous in moist, low-acid foods because it can favor Clostridium botulinum. That is why botulism is the shadow hanging over this whole topic. If a food is low-acid, wet, sealed, and not properly heat processed, you have created exactly the kind of environment where the wrong microbe can win. That is also why swollen or leaking cans are such a red flag. There is another twist. A food can be safe when dry and risky once you add water back. Rehydrating powdered milk, freeze-dried meals, or dried ingredients raises water activity again. The clock speeds back up. So the phrase "doesn't expire" only really applies to the product in the right package, in the right state, under the right storage conditions. Change those conditions and you change the answer. That is the real lesson. Foods do not last forever because they are special. They last because humans, or nature, remove the things spoilage needs. Available water, friendly pH, oxygen, warmth, or microbial opportunity. So the next time you see honey, soy sauce, a bag of rice, or a can on a pantry shelf, do not think, "This food beat expiry." Think, "This food beat the biology." And that is a much better story, because it turns a cupboard full of boring groceries into a masterclass in chemistry, microbiology, and engineering.